6, and I'm going to cover two concepts in this lesson. One of them is beats, and the other one is comparing standing waves and traveling waves. So this is for year 13 physics. So what's beats? Beats is an example of interference. For beats, you need two sources. So when two waves of similar frequencies travel through each other, they will interfere both constructively and destructively, resulting in alternate pulsing of loud and soft sounds. This is called beats. Now, the beat frequency is given by the difference between the two frequencies. This tells you that it's an absolute value, it cannot be negative. It's just the bigger number minus the smaller number. Now, the frequency of the note we hear is the average of the two frequencies, and it is F1 plus F2 divided by 2. And here are two questions on beats. So this one, a piano tuner hears beats at 3 hertz between a tuning fork and top C of the piano. So what are the possible notes? It could be 3 hertz higher or 3 hertz lower. Okay, and then here, a violinist hears 2 beats per second when tuning her violin to a note of 440 hertz. So it could be hearing 2 more, 442, or 2 less, 438 hertz. Okay, moving on to compare standing waves and traveling waves. So traveling waves, they actually carry energy without the movement of the material medium, and it consists of crests and troughs. Each particle vibrates eventually with the same amplitude, and each particle is slightly out of phase with the neighboring particle. As opposed to that, a standing wave is an example of interference. A standing wave is created when two identical traveling waves go through each other in opposite direction. There is no energy transfer in a standing wave, and all the energy is trapped in the wave. A standing wave consists of nodes, these are your nodes, and antinodes. Nodes are points of no disturbance, and so no energy change takes place at the nodes. Antinodes are regions of maximum energy change as energy changes from kinetic to potential. All particles in one half of the wave are in phase, and they're in the opposite phase with the particles in the adjacent half. So these ones are going this way, the other ones are going the other way. Now, all particles vibrate with different amplitude. So the ones over here vibrate with maximum amplitude. The ones at the nodes hardly vibrate at all.